In this slice of physics, I'm going to talk about light and reflection. So the first question is how we can see things at all. So if I'm over here, and this is my eye, and let's say I want to look at a tree. So here's a tree. And then up here is the sun. So now the way that I see the tree is the light comes out of the sun and it hits the tree. And then from that ray of light, green light is reflected. The rest of the light is not reflected. And it comes and hits my eye and it goes back and hits the back of my eye. So now how do I see, for instance, another aspect of that tree? Well, light could come down there, and then the green light could be reflected, and it could enter my eye and hit the back of my eye, and then I would be able to see that part of the tree. So that's the general story, is that the light of the sun is what allows me to see the tree. Now, one question is, can I tell by looking at the tree that the light came from the sun? And the answer is no. Just by looking, you can't tell where the light originally came from. All you can tell is where it came from just now. So, what you can tell by looking is the direction light just came from. That's all you can tell, where it just came from just now. So I can tell that the light came from these directions, but I can't tell that it originally came from the sun. I can deduce that by noticing that the day is very bright and sunny, but on the other hand, it could be that that light came from, maybe the sunlight hit a cloud, and then the light bounced off the cloud and hit the tree. So maybe it came from a cloud. Maybe the last place it was at before the tree was a cloud. Maybe there's a really bright light bulb on someone's house, and maybe that light came from the light bulb. Could have come from a number of different places, but all I can tell is just by looking is the direction where the light came from in just now. So now let's apply this idea to a mirror. So here's a mirror. Let's say this is a mirror in my house, and let's say that I'm here and I'm looking at the mirror, and let's say there's a plant that's over here. This is an overhead view now. I'm looking from above. Okay. And maybe there is a light bulb. So maybe here there's a light bulb in my house. And light from that light bulb then will hit the plant. And then from that plant, it will hit the mirror. And from the mirror, it will hit my eye and go to the back of my eye, and then I can see the plant. So I can tell that there's green light, but it looks to me like that light just came from the mirror. All I can tell, remember, about this light is where it just came from. Now where it came from originally, which was the light bulb, or where it came from after that, which was the plant, but where it came from just now, which is from the mirror. So it kind of looks like the light came from the mirror. And also remember that the only thing I can tell about this light is its direction. The direction where it just came from. Not how far away it came from, but its direction. So that means it looks to me like the light could have come from, it came from the mirror, but I can't tell whether it came from the mirror or whether it came from behind the mirror. So actually it tends to look like things came from behind the mirror. Actually, the place that I most likely to think that the plant is located at is right here behind the mirror. So this is called the virtual image. The virtual image of the plant is back here, which is where it looks like the plant is located. So the rule that tells you how this light reflects is just that this angle, which I'll call theta I for theta incident, is equal to theta R, theta, the reflection angle. So we say that the angle of incidence equals the angle of reflection. So if I were to trace another line of light from the plant, it might go to this place, and then it might bounce off the mirror and into my eye again. So different parts of the plant I would see as being located at different points in the mirror. And so I would see their virtual image located at different locations as well. Right? Okay. So one last thing I want to talk about. So have you ever tried this experiment where you have two mirrors that are at 90-degree angles from each other, like this? What will you see? Well, this time, what I see here, what do I see when I look in the mirror here? Well, the light that's coming to my eye from this direction in the mirror will first come from here, and that will come from here. So that means that what I see as being directly in front of my eye is coming from back here. So if my plant is here, then I'll see it in the mirror as being directly in front of me. If there's another plant here, then where do I see it? Sorry, actually what I wanted to say was that this bush can be seen not only in that way, but I can also see light that's reflected like this, and I can also see light that's reflected like this. So this same object can be seen in 3 different places in the mirror. So things become kind of complicated once you have a lot of mirrors. Okay. So today we've talked about light, and we've talked about the fact that you can only see the direction that light is coming from. You have no way of knowing for sure where that light originally came from. And that means that when you see an object in the mirror, You can't tell where the light originally came from. You don't know where the object is without going to look for it, but it looks to you instead like the object is inside the mirror. And we talked about how the angle of incidence is equal to the angle of reflection.